So transmitter is moving directly towards the receiver at 250 meters per second. And the wavelength of transmission is given as 5 centimeters.
5 centimeters.
You asked to find out the frequency shift in kilohertz at the receiver. So in such cases, you have no other choice but to take to assume that the receiver is stationary and the transmitter is kind of moving towards the receiver. So we have a stationary receiver, and say for example you have an aircraft that is transmitter, so it's moving towards the receiver at 250 meters per second. The wavelength of transmission is 5 centimeters. You're asked to find out the frequency shift that the receiver would experience. Since the aircraft is moving towards the receiver, we know that the frequency shift is going to actually increase, and that is because it is thrusting towards the receiver and the relative velocity is higher. Okay. But since the receiver is actually stationary, whatever relative velocity you find out will be basically the velocity of the transmitter, and that is what is given as 250 meters per second. Using the same equation, velocity of transmitter divided by c is equal to, relative velocity by speed of light is frequency shift by frequency of transmitter, and since receiver is stationary, relative velocity is same as velocity of the transmitter, which is 250 meters per second. Speed of light is 3 times the power 8 meters per second. Frequency shift is asked in the question. You are asked to find out, and you have to find out frequency of transmission given wavelength is 5 centimeters. So we know product of frequency and wavelength is speed of light. Therefore, frequency is equal to speed of light by wavelength.
Frequency is coming 6 gigahertz.
Right, 3 times the power 8 divided by lambda is 5 centimeters. Remember, this is in meters per second. Therefore, you have to convert this to meters by multiplying with 10 to the power minus 2. And how much are you getting?
I'm getting 6 gigahertz.
6 gigahertz. So substituting that here, giga is 10 to the power 9 hertz. Therefore, the Doppler shift frequency or the beat frequency will be 250 into 6 into 10 to the power 9 divided by 3 into 10 to the power 8.
5,000.
That's right. So what is that 5,000?
So just
5,000 is hertz.
yeah,
Right? Therefore it is 5
kilohertz.
kilohertz is the shift in frequency. Now can you tell me what is the observed frequency of the receiver? This question you asked to find out frequency shift, but yes, what is the
6
observed?
gigahertz, 6 gigahertz plus 5 kilohertz.
So whatever incoming frequency is 6
Gigahertz, which we calculated.
6 gigahertz, and since it's coming towards the receiver, the frequency shift gets added
up.
So it's 5 kilohertz.
Kilo.
You don't have to find the sum here, just understanding that it gets added up, right? So look at this equation here, the equation which we have used, that is relative velocity divided by speed of light is equal to frequency shift by frequency of the transmitter, right? Now, what is this? What does these two factors give you? Speed of light and frequency of transmission. The speed of light and frequency of transmission is automatically going to give you wavelength. So it's the speed of light divided by frequency of transmission is the wavelength, right? So wavelength is equal to speed of light divided by frequency of transmission. If I take the speed of light all the way straight here, then I can form that equation for wavelength. So relative velocity divided by is equal to frequency shift into c divided by transmitter frequency. I've just taken c all the way up. Now what is the c by f? C by f, f of transmitter. Therefore this is basically the wavelength of transmission, right? So relative velocity is equal to frequency shift into
wavelength of transmission.
So you can even...
But that should be in meters.
Yeah, so if this is meters per second, this has to be in meters and this has to be in hertz. That's how it works. So basically, I wouldn't recommend you to buy heart this. It's not required. You can still use this equation. But only thing is, this will prevent you from actually finding out the frequency. It's not required. You can, if you have, since the wavelength is given the question here, you can save some time by directly substituting the wavelength. Because it's quite easy here. You can see asked to find frequency shift here. Just divide this 250 by the wavelength of 5 centimeters. Right? So frequency shift is equal to relative velocity by wavelength of transmission. The relative velocity, since one of it is stationary, is basically the velocity of the other, which is 250. Now what you have to be careful here is again with the units, because it's 250 meters per second. However, the wavelength that we have is in centimeters, so we have to convert that to meters. Just 5 kilohertz. Happy? That's just a quicker way of doing it without actually finding out the frequency. But again, I'm completely happy if you can remember this equation and do it the same way. That's completely fine. You don't have to additionally remember an equation. It is just derivation of the same. Alright? Yes, perfect. Let's write another question.